Hello everyone, in this video I will show you how to solve using Prim's and kruskal algorithm. We will start with Prim's algorithm first. Here the three given, the example from the slide. I will show you how to solve it step by step. Right, from this diagram, we will start with A, and from A we need to find what A is connected to. A connected to B, connected to F, and connected to A. So A, we will start with A, and we list down all. So when we list down, B connected to A by 3. Then we have F connected to A by 5. And we have E connected to A by 6. And then we have here, we have C and D. So C does not connected to anyone, so just by infinity. And D same. So from here, which one is the cheapest? So which one is the shortest? So the shortest is B. Then we take B. So the tree will be like this. And we take B here. So A3. Then if we take B, we have A and we have B connected. Then we need to find which node is connected to any other node. So which node is connected to A and B, A or B. So we have C. So we have C. We have F connected by B or connected by A. But which one is the shortest? The shortest is 4, so we take this path instead. And then A connected to E. Right. So we list down again. Okay, C connected to B by 1. F connected to B by 4. And E connected to A by 6. Meanwhile, we don't have D connected to any node. So we will get it here, infinity. Alright, so which one is the cheapest? The cheapest is CB1. Then the tree will be like this. So A connected to B, connected to C. Right. So will be CB1, and we have A, B, and C. Okay, what node is connected then? So we have connected to D. Also we have connected to F or C. It is the same short, so we just choose either one. And then A to E. Right, so we list down here. We have D connected to C through by 6, and F connected to B by 4, and E connected to A by 6. Which one is the shortest? So the shortest is F. Alright, so we choose F here. Then the current tree will be A to B to C and to F. Alright, so I'm saying we choose this F, B4. Then we have here C and A. Sorry. Alright, so next, which one is connected to E? F and A, right? Which one is the shortest? The shortest is 2. So we choose this path. And which one is connected to D? We have C and F. Which one is the shortest? So the shortest is through F. Right. So here we list down. We have D connected to F by 5, and E connected to F by 2. And then we choose the shortest path. So we choose, we choose E because the path is 2, the cost is 2. Alright, so we will get here. And then the final one will be A connected to B, connected to C, and B connected to F, F connected to E, and finally we have E, F by 2, and we have D, F by 5. How? Because when D is connected to C, 6, this is 5, and this is 8. Which one is the shortest? The shortest is Y. So we get is 5. So the final one is D5. So this is the 3 verticals we choose. And then from here, we need to find the weight. Right. To find the weight, so we have it. We have here the weight is, we just plus with 3, plus with 1, plus with 4, plus with 2, plus with 4. So here we will get weight of 3 equal to 3 plus 1 plus 4 plus 2 and 5. We will get here, we will get here 15. Alright, we will get 15 here. Alright, so how the tree will looks like? The tree will looks like this. Okay. A connected to B by 3, connected to C by 1, connected to F by 4, connected to E by 2, and connected to D by 5. So this is the total cost. We just add all to find this weight. Alright, so this is for the example for Prim's algorithm. Let's move to the second example for Prim's algorithm. Here I just copy it. Okay, we have to find 3 verticals and remaining verticals. So let's try to answer this. We will start with A. Okay, we will start with A. We will start with A. So just screen. Okay, A. So what's node connected to A? We have to B and we have to D. So we have 2, and the other is infinity, we does not connected, so we just don't list it. So we have B, we have A, B connected to A by 4, and also we have D connected to A by 1, and we start with A, right? Okay, so we can just write it like this. Okay, A, we have A, and then from here we choose it the cheapest, the shortest. So the shortest is D, so we take D. Okay, we have A, we have D connected. So what's the other nodes are connected? So we have B, either by A or D. It's same distance, so we can just choose either one. So I will just choose from A. And then we have H connected to D by 5. We have J connected to D by 6. Right, so that's all. So we just list it here. We have D, A1. Okay, we have B connected to D by connected to A by 4. We have J connected to D by 6. We have H connected to D by 5. So which one is the cheapest? So the cheapest is B connected to A by 4. We take this note, so we will write it here. We take A, I'm sorry, should be this, we take D already, right? So D, and then we have D, and we have B. Next, since we already A, we already have B, we already have C, B, A, B, and D, then we need to find what connected to A, B, and D. So we have C connected to B. Okay, we have D connected to H. We have D connected to R and J. Also, we have B connected to J too, but which one is the shortest? We have through D, because it is 6, so we just don't use this, right? Then here, since we already choose this, I will just write here B, A, and 4. Okay, and then we list down C connected to B by 4, and H connected to D by 6, I by 5, J connected to D by 6. Which one is the cheapest? The cheapest is C, B, 4. Then we have A, we have B, we have C, we have D. Alright, so we have C, B, 4. So here we already take it A, D, B, and C. Right. So next, we need to list down what is connected to A, D, B, and C. So C is connected to the E. C also connected to F. Okay. D connected to H. D also connected to J. And also J is connected to B, but connected to D is shortest. Right. So we just H connected to D by 5. J connected to D by 6. E connected to C by 2, and F connected to C by 1. Which one is the cheapest? The cheapest is this. So we have F, C1, right? So we already get this. So we take F. Okay. Alright. So this is our current tree in the green color. So here we have T, we add more, D, B, C, and also we have F. Right. So next we need to find which one is connected to which. So C is still connected to E, F is connected to G, and also F is connected to I, and D to J, D to H. So we have all here. So E is connected to C by 2, G is connected to F by 3, I is connected to F by 5, J is connected to 6, J is connected to D by 6, and H is connected to D by 5. Alright. Then which one is the cheapest? The cheapest is E. We take E here. So we have D, we have A, we have B, we have C, we have F, we have G. I'm sorry, we have E. We take E, right? So we take E, C2. So from here, we will get T, A, D, B, C, F, and E. Alright. So this is our current tree. So next, we need to find out what is connected to what. So G is connected to F and E. So which one is the shortest? We choose A path. And also I is connected to F. Also we have H connected to and J connected to. So we list down G, E 2, I, F 5, G, D 6, H, D 5. Which one is the shortest? So the shortest is G. Alright. Sweet. I will copy to there. Okay, let's move to the next this part. Okay. Okay, this part. Jap, wait. We have A, we have D, we have C, E, F. So we have disconnected. Right, so we have G. So wait, I will just write. Okay, we have G. So we choose G, E, and 2. So we have A connected to B, connected to C, connected to E, connected to F. We have connected to D. Also we connected to G. Alright. Next, we need to find out what is connected to what. Okay. So here, J, we have either by D, B, or G. Which one is the shortest? So the shortest is 4. And I is connected to F or G. So the shortest is G. And here we have H only connected to D. Then we list down H, D5, J, G4, and I, G3. Alright, then we choose the shortest. So the shortest is IJ3, IJ3. So we have A, B, C, E, F, and G, and D. And also we have I. So what is connected to what? We have H still here, and also we have I here. So we choose I J here because this is shortest. Then we have 3, 4, 10, and 6. So when the shortest, so the shortest is J. So we have J by I 3 and H by D 5. So the shortest is J. We choose J here, I 3. So we have these 3. So next, which one is connected to? We have H connected to D or J. So we choose J here. Alright, J, H2. So then this one will be J, H2. Alright, I forgot to list down the T. Okay, T here will be A, B, D, B, C, F, E, and G. Alright, I will just grab it all here. K for all, it will be T, A, B, A, D, B, C, F, E, G, I, J, and H. I'm sorry. I was wrong here. Okay, I was wrong here. I'm sorry. It should be H through J by 2. So H through J by 2. Right. So our tree will be like this. D connected to A by 1 and connected to B by 4 and connected to C, by 4 connected to E, by 2 connected to F, by 1, okay, connected to G, by 2 connected to I, by 3 connected to J, by 3 and connected to H, by 2. Right, so we need to find weight of 3 will be 1 plus 4 plus 4 plus 2 plus 1 plus 2 plus 3 plus 2 plus 3. So we will get here 22. So this is Prim's algorithm. Right. So this is Prim's algorithm. Next, we move on to the example for kruskal algorithm. So this is example for kruskal algorithm. Okay. This is example for kruskal algorithm. Let me help you solve it step by step. Okay. To solve this step by step, we need to list down all the sorted lists, all the lists between node to node, node to node. But we need to sort it increasing. Okay, we will start with 1. Okay, B to C is 1, and next to F E is 2. Next is 3. A B is 3. We have 3 no more. Okay, we have 4. B F 4, and also F C 4, and we have A F. Okay, we have A F 5. We have F D 5. Okay, wait, I move it. Okay, F D 5, and also we have 6. C D 6, A E 6, and E D 8. Alright, I need more. Okay, from here we need to choose the shortest one. Okay, we choose from the left, right? The shortest one is BC. So BC here. So we have the option here, B and C. Next, the shortest. Okay, the shortest next. Since we already have B and C, we slash them, so we don't need it anymore. And then, okay, next we need to find the shortest. Okay, so we have 3 each here. We have BC. Okay, BC. Then we have FE. FE. So we move FE. So we have FE1. So we already have this. I mean FE is 2, sorry. Okay, next we have A and B. Okay, A and B. So we can connect this A and B. Okay, A and B. Alright. So A and B with C and F with E. So we have A and B 3. And then we have next we will have F BF. But now, okay, we have BF. Okay. So we have BF. So we take BF here. So we have this, and this. Okay, next we have, okay, FC. But when we take FC, this will not be a 3 anymore. So we just skip FC. Here FC, and we move to AF. So does we need AF? No, we skip 2. Next, FD. So we can take FD. So we take FD. So FD 5. So we already complete the tree here. As you can see, all nodes are connected to each other. So okay. So now we need to calculate the weight. Right. So how to calculate the weight? We just calculate all. 1, 2 plus 2. Okay. Okay. 1 plus 2 plus 3 plus 4 plus 5. Right. So that's all for kruskal example 1. So we move on to example next. Okay, same goes to the previous set. We need to list down all our okay. We need to list down all our connection with A to A to B. Okay, we have A to B here, B to C, we have B to C, and we need to sort it by increasing. Start with increasing. Okay, so we will start with the first one. Okay, the first one, A to D. A to D. I will choose this color lah. A to D. So we start with A to D. Okay, we take it. Okay, we take it. So next, C to F. C to F. So we take it to. Okay. And then we have C to E. C to E. Okay, then we take it to. And we have E to G. E to G. Then we take it to. We have H to J. H to J. It doesn't make it triangle, so we can take it. Okay, we have F to G. F to G. Which one? F to G. If we take it, it will be shape here, so we can't take it. Okay, next, G to I. G to I. We can take it. Alright, so next, I to J. I to J. Yes, we can take it. And then A to B. A to B. Yes, we can take it. And then we have B to D. B to D. We can't take it because it will be triangle, so cannot take it. And then B to C. Yes, we take it. So now all is connected, right? A, D, B, C, E, F, G, I, J, H. When all is connected, then it's done. This is our tree using kruskal algorithm. So that's all for this video. Thank you.